The focus of this video is about Cpctc, which stands for congruent parts of congruent triangles are congruent. Okay, so that acronym is pretty much talking about like you can prove any part of a triangle is congruent to another as long as the triangles are congruent. And that's kind of how we started this entire unit. I would say, hey, these triangles are congruent. And then from there, you would tell me which angle is congruent to which and which side is congruent to which. So now you have to kind of do both. You have to first prove that they are congruent, just like we did in the previous video or the previous proofs. And then your last step is now going to say, well, hey, since they're congruent, now this other part is congruent that I didn't know because of Cpctc. So let's take a look at one of these. So please remember that the structure of proofs are going to remain the exact same. So they're not going to change how they're structured, okay? So let's start again with our givens. And in this case, I have two. And you can see the first here and then the second here. So I'm going to list those first. So WV is parallel to YZ, and that's given. And I'm going to mark that on this graph because I don't want to forget. So here are my parallel lines. And then it says that X is the midpoint of WY. Okay, and that's also given. So there's definitely some words that I'm going to highlight here or symbols. Parallel and midpoint are something I could do something with. I'm going to start with midpoint because it's less complicated. So if X is the midpoint, so if this is the midpoint of WY, so it's the midpoint of this segment right here. So that tells me that WX is congruent to YX, and that's because of the definition of midpoint. And I'm going to label that right now. So I have a segment there and a segment there. And then I'm going to do the parallel lines next. And I think I'm going to use okay, so think about it this way, sorry. So let's say this is parallel here to this. And I'm going to use that blue line as a transversal. That transversal is giving me some alternate interior angles here and here. So I'm going to say that angle W is congruent to angle Y. And the reason I can use one letter here is because there's no other angle that can really exist there. And that is alternate interior angles. And then I have one more thing that I need, and I think I'm going to grab this vertical angle in the middle. So I have to use three letters for this one. So VXW is congruent to ZXY, and those are vertical angles. So now is when I'm kind of ready to talk about the triangle proof, because I've talked about a side, an angle, and I just have to think about the order of those. So if I start here, I've got an angle, it looks like angle, side, angle. So angle, side, angle here, and triangle VXW is congruent to triangle ZXY. Okay, so now is where I've already proved the triangle is congruent. So now I get to prove that this angle right here is congruent to this angle. And because the two triangles are congruent, I get to say that. So my proof statement from above, that's right here, WVX is congruent to angle YZX, and that's because of Cpctc. All right, let's see here. Let's try this one up here, and that will be all for us tonight here. So I have two givens. I have AC bisects angle BCD, and I have angle ABC is congruent to angle ADC. So I'm going to mark that first. So ABC is congruent to ADC. I'm going to mark that. And then I can see that there's a word that I can kind of go after, and that's bisects. So that's going to be the first thing I talk about then. So AC is bisecting BCD, this angle right here. So that gives me that this angle and this angle are congruent. So I'm going to say that next. I'm going to say angle BCA is congruent to DCA, and that's because of the definition of a bisector. And I forgot to put given up here. All right, so I've got two angles. I just need to be able to say something else, and then I realize what it is. The two triangles are sharing this side right here. So I'm going to say that AC is congruent to AC, and that's the reflexive property. So now we've got all three pieces that I need. I just have to think about the order. So if I start where there's nothing, I have an angle, and then a side. So I'm going to say that triangle ABC is congruent to triangle ADC, and that's by angle, angle, side. So now that the two triangles are congruent, I now get to say this last statement, that AB is congruent to AD, and that's by Cpctc. The one more thing I want to make very, very clear when you're doing proofs is that when you have triangle, let's say ABC is congruent to triangle DEF, you know the ending of your proof will be like side, 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 angle, side, angle, angle, side, angle, or HL. If you're given like angle A is congruent to angle E, or AB is congruent to DE, something like an angle or a side, if you're given this as your ending proof, like again, it says it right here, then this is, you're going to end all of your proofs with Cpctc. So please keep an eye on like, what am I trying to do and how far do I have to go to prove that? So that's kind of one last little bit of information to kind of help you identify which type of proof you're doing. Like always, if you have any questions, please reach out to any of us to help.